everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about this engineering tribology subject. So we have covered so far friction related topics and wear and lubrication and corrosion. All modules we have covered. And definition terminology and related to the question bank, how to attempt the questions, how to attempt the answers uh, for this related to this engineering tribology topics we have discussed. So in this today's topic, I will explain the super alloy materials questions, the related the model paper questions. So the model paper one questions and answers the topic related to the super alloys. So already you know the advanced alloys and super alloys are classified into different types and applications also we have seen. But again, here in model question paper, he has asked a question differentiate between advanced alloys and super alloys. So how to give briefly that should be related to this advanced alloys and super alloys only. So both advanced alloys and super alloys are high performance materials used in various engineering and industrial applications, but they have distinct characteristics and specific uses. So already we have discussed. So the advanced alloys. So first we will see advanced alloys and then applications and super alloys we will discuss, and you can write the difference between these two alloys. The advanced alloys, see the definition is advanced alloys refer to a broad category of alloys that exhibit superior mechanical, thermal and chemical properties compared to conventional materials. So the mechanical and the thermal properties, and chemical properties, So mechanical properties already we have discussed, the strength and hardness, ductility, malleability, and other properties are there, the fatigue property. So they include a wide range of alloy systems engineered for specific applications, so requiring enhanced performance. All these properties, so the applications are requiring to enhance the performance of the component. So the characteristics are enhanced properties. So designed for improved strength and then toughness, corrosion resistance and other specific properties. So the varied composition can include a variety of metals and elements tiled for specific applications. And then the applications are used in automotive, aerospace, electronics, construction, and other industries. So having these characteristics, this so advanced alloys, so that the material super alloys are used in automotive sector and aerospace. So there the high resistance to corrosion and strength and the temperature is required, so that these advanced alloys are widely used in these sectors. Examples, see the titanium alloys, known for high strength to weight ratio and corrosion resistance. Aluminum lithium alloys, used in aerospace for weight reduction and high strength. High strength steels, engineered for durability and performance in automotive and construction applications. So examples are titanium alloys, aluminum lithium alloys, and the high strength steels. So these are the examples for these advanced alloys. So it gives high strength to weight ratio and also having corrosion resistance. So that's widely used in these sectors. Next one, coming to the super alloys. As per definition, the super alloys are a specific subset of high performance alloys. These materials are advanced alloys and super alloys are called as high performance alloys designed to withstand extreme environments. So particularly high temperatures and corrosive conditions. So they are known for their exponential mechanical strength. So having very high mechanical strength, the resistance to thermal creep deformation. So mechanical strength is the mechanical property and thermal creep is also mechanical property and good surface stability. So having good surface stability. So these are the soap alloys properties. The characteristics: high temperature performance. See, these soap alloys can maintain strength and stability at temperatures often exceeding 1000 degrees centigrade. So wherever the temperature is 1000 degrees centigrade exceeded, there these materials are used. The necessity is there due to it gives high temperature performance. So maintain strength and that much of capacity having the corrosion and oxidation resistance. So this one also this material having a high resistance to the degradation and in harsh environments. So whenever the component or the material exposed to harsh environments, so there is a resistance to the degradation or oxidation process. So due to this property, you can minimize the corrosion and oxidation process. Complex alloy. So often composed of nickel, cobalt, or iron-based alloys with significant additions of chromium, molybdenum, aluminum, and titanium and other elements. So these are alloying elements. So that's why the materials are composed with additions of this chromium, molybdenum, and aluminum, and titanium, and other elements. Next, what are the applications? The applications are turbine engines. In turbine engines, aerospace and power generation. Blades, vanes, and other critical components. So in turbine engines, many components are there. So due to high resistance capacity of this material, so the material is used for these turbine blades. Similarly, vanes and also remaining components. The chemical and petrochemical industries, reactor vessels, heat exchangers, and other high temperature equipment. So the marine applications like components exposed to high temperature and corrosive sea environments. So the sea environment is different and then the normal environment. So the components exposed to high temperature and corrosive, so there must be chances of corrosion. So to avoid this corrosion, the components made up of this material. So that's why before designing or before manufacturing, the selection of material is very important. Already we have discussed in earlier sessions. So based on that application, you should select the material. So the application, your product, the design product, the application is marine application. So that the component having good characteristics and good properties to withstand the sea environment conditions. So examples: Inconel, so nickel chromium based, used in jet engines and gas turbines. Astalloy, nickel molybdenum, known for excellent corrosion resistance, used in chemical processing. So the detailed about this Inconel nickel chromium based and nickel molybdenum based we have studied in a previous session. Under the material discussed about nickel chromium based alloy, nickel molybdenum based alloy already we have seen. So the example for this soap alloys is again shown in here, the material, the astalloy, known for excellent corrosion resistance. and used in chemical processing. Rainy alloys used in aerospace applications, the turbine blades, and other high temperature components. So the main differences, what are the main differences between these two, advanced alloys and super alloys? The key points. One is temperature tolerance. The advanced alloys generally have enhanced properties compared to conventional materials, but may not be suitable for extremely high temperature. So the advanced alloys are having some properties compared to the conventional property materials, but not suitable, not be suitable for high temperatures. The super alloys specifically designed to retain strength and stability at high, extremely elevated temperatures. These alloys are designed to the strength and stability. So that's why these super alloys are having this temperature tolerance. The applications applications are advanced alloys, broadly range of application across various industries. In super alloys, primarily used in high temperature, high strength, high stress environments such as aerospace and power generation. The material composition. So advanced material composition and super alloy composition you have to write here. So the advanced alloys are composed can be based on various metals. Already we have seen titanium, aluminum and steel, etc. These are the advanced alloys. These alloys are composed with other materials. So additionally added some materials, chromium, molybdenum, magnesium, like that. So that is depends upon the material characteristics and the requirement of application. The super alloys are typically based on nickel, cobalt, or iron with complex alloying to enhance high temperature performance. Next question. Explain the composition of polymers and list out its application in details. In previous question paper, he has asked about polymers. So briefly, types of polymers and the advantages and disadvantages of polymers. But in this, he has asked to explain composition of polymers and list out some applications in detail. The composition of polymers are large molecules made up of repeating structural units called monomers. The repeated molecules are here monomer. So finally obtained the polymer. It is a combination of different monomers which are covalently bonded to form long chains. The properties and types of polymers are determined by the nature of the monomers, the structure of the polymer chains and the interactions between chains. As to basic components, monomers. The building blocks of polymers. Common monomers include ethylene for polyethylene, propylene for propylene. The polypropylene is called propylene. Vinyl chloride for PVC pipes, vinyl chloride. Styrene for polystyrene. So building blocks of polymers. The common monomers include these are all monomers. The repeating units, the specific arrangement of atoms within a polymer that repeats to form the long chain. It gives polymer. The long chain gives polymer. Okay. Additives, substances added to polymers to enhance properties such as plasticizers, stabilizers, fillers, colorants, and flame retardants. See, types of polymers already here given. One is natural polymers and synthetic polymers. So the natural polymers occur in nature. There is cellulose and proteins and DNA. Synthetic polymers are man-made, polyethylene and polystyrene. Polymer structures already we have discussed in theory part. Linear polymers, branched polymers, cross-linked polymers. The consist of long and straight chains are called linear polymers. The branched polymers are attached to the main chain. So low density polyethylene and network polymers. The applications already have discussed in the theory part. So here once again you see packaging, wide range of applications due to their diverse uh, properties. So polyethylene used for plastic bags and bottles. So polypropylene used for food containers, yogurt plots and bottle caps. Polystyrene used for disposal cups, plates and packaging foam. And polyethylene terephthalate, so that is PET, used for beverage bottles and food containers. The automotive sectors, polycarbonate, used for headlights and windows. Acrylonate butadiene styrene, that is used for dashboard components and body parts. Nylon, used for engine components and under the hood applications. Polyurethane, used for seats and foam. The construction field, you can see various applications. Polyvinyl chloride, polystyrene, polyethylene. The electronics, mainly electronics used for display screens and electronic housings and optical discs, used for wiring, insulation and cables. So the medical field, medical tubing and bottles, syringes and medical containers. So wound dressing and medical devices, and implants and medical seals are silicone. These are the application. Then textiles, polystyrene, nylon, acrylic, and consumer goods, polystyrene and polyethylene and polypropylene. These are the applications of this polymers. In aerospace, used for coating and seals. High temperature applications and insulation. Wherever required the high temperature, there the high temperature applications and insulation purpose use these polymers. Carbon fiber reinforced polymers, used for structural components and lightweight parts. In agriculture, used for greenhouse films and irrigation pipes, used for nets, twines and non-woven fabrics. Sports and recreation. You can see see the used for the elements and protective gears and sports items, sports shoes and equipment padding, used for kayaks and playground equipment. These are the references I have taken for this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.